Hi, this is Mr. Ward, and I'm going to talk about super simple linear equations. These are going to be linear equations that go through the origin, go through 0, 0, and some point. Um, they involve just a whole set of y values and x values, where every y value is exactly the same number. It's some number times the x value. It's just going to be always consistently the same number. So y equals 2x would mean you have all y values are 2 times the x value. Y equals negative 5x means every y value is negative 5 times every x value. And so to demonstrate what this might look like, we'd say y equals, let's say, 2x, and you get an infinite set of xy points that are all the y values are all 2 times the x values. Sometimes it's easier to see when you get a whole number like 3 and 6 or 4 and 8, but those decimal ones near it are also going to be 2 times the x value. The y values will be 2 times the x value. And we can make a table and we can plug that in here. So I'll make this x, and this will be 2x. And I will just say negative 4, negative 3, and whatever I put in there is going to be 2 times the x value. The y values will be 2 times the x values. And notice that when it's x is 0, y will be 0 too, because 0 times 2 is just going to be 0. So that means this line will go through the origin at 0, 0. Okay, let's say I change this to f of x equals 2/3 x. Okay, and my new rule is for f of x, I can just put the f of x right there. Every x value will be multiplied times 2/3 and get a y value. Negative 3 times 2/3 will be negative 2. Negative 1 times 2/3 will be negative 2/3. 1 times 2/3, that's the repeating decimal is 2/3. It's rounded at the end. But as you can see, all the points make a nice straight line, and it goes through the origin. All right, so what's the usefulness of this? Well, there's a lot of situations where you might use this is called a direct variation. So you might use these direct variations where y varies directly by some scaling factor. It is multiplied by some specific number. X is multiplied by some specific number to get y values. So inputs are multiplied by some number to get an output. So, for example, a job. If you have a job, you may get paid an hourly wage. So let's say you are being paid $30 per hour to do some task. Okay, so I'm going to call this the function j for x. Well, x will be time. Okay, and that's going to equal, let's say, $30 an hour. This is 30 times x hours. So that makes a pretty steep graph because 30 times y is going to be a big number. We can plug that into a table and you can see it a little more clearly. So I'll say x and j of x. Since you're working, I'm going to, at 0 hours, you'd make $0. At 1 hour, 30, and so forth. So you're making decent money. After 8 hours, you'd have made $240. That's pretty cool. There are other situations. Let's say j of x was not about money. J of x was about how many pounds of dog food you're buying. Okay, so dog food, if you're buying it in bulk, maybe it costs $3.22. Okay, times x, number of pounds. So now we've got a direct variation where every output, every j of x or every y, is going to equal 3.22 times the number of pounds. So at 0 pounds, you're paying $0. 1 pound, $3.22. 2 pounds, $6.44, and so on. And you could use this to predict, you can get a lot of dog food. Maybe you're getting 34 pounds of dog food. So it's going to be a little pricey there. $109.48. but you can use this to model situations like that. So anytime you're modeling something where we're simply directly multiplying an input by a number, and that's all we're doing, this very simple linear function will work. Now, you might be wondering how to deal with this in Laser Cannon Battle Commander too. So let's actually go there. So if we go into this, so you have two things to do for this level. You've got a testing out thing. We just need to work out some stuff with these direct variations. And the direct variation questions that you're going to have are in this little testing out thing. You need to come up with an equation. Actually, this is something I should talk about a little bit. You should come out with an equation that goes through 2 points. So I've worked it out like just coming up with the points from an equation, but now we're going to talk about an equation that goes through 2 points. And that's going to be useful also for the Laser Cannon Battle Commander. So let's talk about that. What if we have 2 points? Let's say we have the point, and one of them is going to be 0, 0. Okay, for these simple linear equations, one of them has to be 0, 0. Because 0 times whatever number will be 0. We're not adding or subtracting anything to it. Okay, let's pick another point. Let's pick the point 24, 36. Okay, so what would be an equation? So if I do y equals x, we're going to be multiplying it times some value. We zoom out a little bit. We got those 2 points. I'm going to zoom out a bit more to get the other point. Okay, so my line clearly doesn't go through that. Well, how am I going to get the number that would work for this? I'm going to use the letter K, okay, and the letter K, I'm going to give it a slider. It's still not working right. What I need for this letter K to equal is something I would multiply x by to get y. Well, if I want to know what I would get multiply x by to get y, I'm just going to have to divide y by x. And I've got a y value here, and I've got an x value. So let's divide that y value by that x value. 36 over 24, which is 1.5. So if I made this equation 1.5x, it works. So let's step back again, because I might have gone by too fast for you. To make a line that goes through 0, 0 and this point, every x value on that line needs to be multiplied by something that would turn the same number that would turn 24 into 36. Well, 36 is 1.5 times 24. So we multiply it by 1.5, it will work. And you can get that number by simply dividing this y value by this x value. Let's say I wanted to make a line that goes through the origin and the point 19, 2. Okay, I'm sorry, 19, comma 2. Okay, let's say I want to do that. There's my point, 19, comma 2. To do that, I'm going to say y equals, and I'm going to divide 2 by 19. So I'll just write 2 over 19, which is a way of saying division, all times x. And that works. It goes right through there. Okay, and let's say I wanted to go through -4, 5, comma 5. Okay, there's that point. Well, now I've got a negative involved, so I'm going to do y equals the y value divided by the x value. So 5 over -4x. Okay, and that goes right through there. Now that negative can move, by the way. You can move that negative right out in the front, because 5 divided by -4 is -5/4, and that works. Now, let's do one last thing, which is how we could make these lines a little fancier. So right now, they just go forever, right? So let's zoom in a little bit. Let's say we wanted it to go just from this point at -4, 5 to 0, 0. So I've got my equation for that. And I go over here next to the letter P, and you'll see square brackets and fancy brackets. And I say shift square bracket, and I get a fancy bracket. And I'm going to make an inequality. I'm going to make I can either do a range inequality or a domain. I'm going to restrict the domain. If I want to restrict the domain, I'm going to go from -4 here is the x value to 0 at the x value here. So I'm going to say -4, -4 is less than, and if I do less than symbol and then I type the equal sign, it merges it. And I'll say x, and I'll do the same thing again, less than or equal to 0. And now I've made my line fancy and limited between -4 and 0 for the x values. I could do it also with the y values. So my high y value is 5, my low y value is 0. So I could say 0 is less than or equal to y is less than or equal to 5. And I can end it with a fancy thing as well. So now I've made it fancy. So with that said, there are questions for you to consider here with Linear Functions 2 Part 1. And then there's a laser cannon battle commander for you to do. So here we go. I will be the Blargian Empire. Okay, that's who I will be. And so here we are. So you've got the Blargian Empire has come to invade the Earth. And we are going to be shooting, and I borrowed this from an older one, so I apologize, it's not updated. It implies you've already done this before, but that's okay. You don't have to have already done this to do this. So here we have the Earth. There's the Earth. The Earth is at 0, 0, okay? And that means we're going to shoot the green Blargian ships using this equation. And if you find the right equation, you might be able to come up with ones that shoot the red ones and all in a straight line too, but let's not worry about that for now. So I've got some green Blargian ships here. I'm going to zoom out a little bit so you can see all my green Blargian ships. So that's a green Blargian ship at 14.3. There's one at 8.5. So if I want to shoot the one at 14.3, I'm going to say y equals x, but I'm going to multiply x by whatever it takes to multiply 14 by to get 3. Well, the thing I'd multiply 14 by to get 3 is the y value over the x value. So I can just say 3 over 14, and that works. And then I'll make it fancy bracket. And then I'm going to say 0 is less than or equal to x is less than or equal to 14. By the way, if you make your inequality and nothing shows up, then you may have made an error in your inequality. Maybe you said 0 is greater than or equal to x is greater than or equal to 14, which would just not be true because 0 is not bigger than 14. Or maybe you have your inequality disagreeing with itself. Less than or equal to x is less than or equal to 14. That actually works, but what if you did it like this? Now, really, you're just saying x is greater than 0 and also greater than 14, so it's just going to be past 14. So that didn't work. So you want to make sure your inequalities agree and are lined up. Okay, so you can shoot any one of these. Your goal is to shoot any one of these points. If you want to try more advanced stuff to try and hit these points from these blue dots, you can, but that's for a later lesson. The next one, you're going to be shooting the green ships from the Earth using the same sort of thing. Now the x values are negative. So let's say we wanted to shoot this one, negative 4711.5. Say y equals 11.5 over negative 47x, and it works. So just divide the y value by the x value, and then you can make it fancy. Okay, fancy bracket. Negative 47 is less than or equal to x is less than or equal to 0. And there you go. All right, so shoot up all the green ships at the very least. Try and shoot the red ones as well if you can. And there you go. All right, good luck. See what you can do.